Welcome to this Fractal Project WP4 demo video. In this training video, we will be showcasing the OS security layer component integration to apply all the designed security countermeasures to our existing Yocto image project. Before we begin, let's take a look at the three main stages of this process. First, we have environment setup where we will prepare the necessary tools to build the image. Next, we will move on to image building, where we will compile the image with the added Yocto layer. Lastly, we will verify the security countermeasures in the system. Now, let's dive into the technical aspects of this process. We will start by setting up the environment.
Before we start, it is recommended that you have an up-to-date Ubuntu machine for the building process. In this case, we will be accessing a remote machine with Ubuntu 22.0 for LTS via SSH. The first step in environment setup is to clone Pokey from the Yocto project repository. This may take some time, so let's fast forward this. Moving on to step 2, we need to clone the dependencies. Specifically, we will clone MetaOpen Embedded. For those who are unfamiliar, MetaOpen Embedded is a layer that provides various recipes for packages that are not included in the base Yocto project. Next, we also need to clone MetaSecurity. MetaSecurity is a layer that provides security-related recipes, tools, and configurations that can be integrated into the system. Now, for step 3, we need to unzip the MetaFractal layer into the Pokey directory. This layer is the result of the security analysis conducted in task 4.4 of the Fractal Work Package 4. It implements all the security countermeasures that were identified during the cybersecurity risk analysis. Lastly, for step 4, we need to unzip the build.zip file into the Pokey directory. This file contains the default configuration for building the image in the next step. It's important to note that any existing configurations will be replaced. Now, moving on to image building, we are ready to build the image with the added Yocto layer.
The first step is to initialize the BitBake environment for building images. BitBake has a script to do this automatically. We just have to call this script and it will configure the console. Now, we can begin building the image using the command bitbake fractal image. BitBake is a build tool that is used to automate the building of software packages and images. It's important to note that this process can take a significant amount of time, but we will fast forward through it for the purpose of this demonstration. When we build an image, we are essentially creating a complete operating system that includes the necessary software packages, libraries, and configuration files. Moving on to the final step, security countermeasure verification. This step involves verifying that the security countermeasures implemented in the MetaFractal layer are working correctly.
To begin the security countermeasure verification, we first need to start the generated image. This can be done using a virtual machine or a physical device, but the necessary options must be configured in the build configuration. In this case, we are using QEMU. It is important to note that the image shown in this demo only integrates the MetaFractal layer and its dependencies, but this layer is designed to be used in conjunction with the rest of the layers that make up the operating system of the Fractal node. To integrate it with other layers, you must add them to the Pokey directory and modify the configuration to add these layers to the build process. Specifically, they must be added to the bblayers.com file, either manually or by BitBake. Once the operating system has booted, we'll log into the image with the default credentials. These credentials can be set in the Yocto recipes of the Fractal layer. The third step is to transfer the verification script. We will transfer the fractal verification.zip file to the QEMU machine. In this case, we have used SCP for the transfer. This script implements a set of tests that check all the implemented countermeasures and verifies if the configuration has been altered during the image building process. It's important to perform this check because the fractal layer is designed to coexist with other layers, which may cause some configurations to be lost. After transferring the script, we need to extract the file. Finally, we will execute the script and check the results to verify that the security countermeasures have been implemented correctly.
In summary, we have demonstrated how to integrate the metafractal layer to build a secure operating system for the fractal node. We have shown how to set up and appropriate the environment, build the image, and verify the implemented security countermeasures. This process helps to ensure that the operating system is secure against potential cyber threats. In conclusion, building a secure operating system is critical for ensuring the security of digital systems. By following the steps outlined in this video, you can build a secure operating system using the metafractal layer. Thank you for watching this video, and we hope you found it informative and helpful.